Welcome to SS2 Further Mathematics, Term 3, Week 4. Curve sketching is the art of drawing accurate, informative graphs of functions using calculus and algebraic analysis without plotting hundreds of points. By the end of this lesson, you will be able to identify key features of polynomial and rational functions, intercepts, asymptotes, turning points, and behavior at infinity, and produce accurate sketches of their graphs. Let us begin. Systematic approach to curve sketching. Step 1. Domain. Identify values of x where the function is defined. For polynomials, all real x. For rational functions, f x equals p x slash q x x where q x is not equal to 0. Step 2. Intercepts. Y-intercept. Set x equals 0. Find y equals f 0. X-intercept. Root set f x equals 0 and solve. For polynomials, factor. Step 3. Symmetry. Even function f x equals f x, symmetric about y-axis. Odd function f x equals f x, symmetric about origin. Step 4. Asymptotes. For rational functions, vertical asymptotes x equals a where q a equals 0, denominator is 0 and numerator is not 0. Horizontal asymptotes. For large x, compare degrees of numerator and denominator. If degree, numerator, less than degree, denominator y 0, horizontal asymptote y equals 0. If degrees equal, y leading coefficient of numerator slash leading coefficient of denominator. If degree, numerator, exceeds degree, where denominator, by 1, oblique, slant, asymptote, divide. Step 5. Turning points and stationary points. Find f x equals 0, determine nature, mark slash mean, using f x or sign of f x around the point. Step 6. Behavior as x plus or minus infinity. Does f x plus infinity dash infinity or a finite value? For polynomial functions, the key features are roots, turning points, and end behavior. End behavior, determined by the leading term x caret n. If n is even and a greater than 0, both ends go to plus infinity U-shape. If n is even and a less than 0, both ends go to dash infinity inverted U-shape. If n is odd and a greater than 0, left n dash infinity, right n plus infinity S-shape going up. If n is odd and a less than 0, left n plus infinity, right n dash infinity S-shape going down. Worked example 1. Sketch y equals x superscript 3, 3x superscript 2, for x plus 12. Step 1. Factor. Try x equals 2, 8 minus 12 minus 8 plus 12 is equal to 0. So, x, 2, is a factor. Dividing, x superscript 3, 3x superscript 2, for x plus 12 equals x, 2, x superscript 2, x, 6 equals x, 2, x, 3, x plus 2. Root x equals minus 2, 2, 3, y-intercept, y equals 12. Leading term, x superscript 3 left n goes to dash infinity, right n goes to plus infinity. F x equals 3x superscript 2, 6x, 4 is equal to 0 x equals 6 plus or minus square root 36 plus 48 slash 6 equals 6 plus or minus square root 84 slash 6 is almost equal to 6 plus or minus 9.17 slash 6, x is almost equal to 2.53, local minimum, or x is almost equal to minus 0.53, local maximum. F x equals 6x, 6, f, minus 0.53, equals minus 9.18 less than 0 local maximum, f, 2.53, equals 9.18 local minimum. Sketch, starts from dash infinity, lower left, rises to local max near, minus 0.53, f, minus 0.53, falls to local min near, 2.53, f, or 2.53, then rises to plus infinity. Rational functions have the form f x equals p x slash q x. They introduce vertical and horizontal asymptotes. Worked example 2, sketch y equals 2x plus 1 / x, 3. Domain x is not equal to 3. Vertical asymptote x equals 3. Horizontal asymptote, degrees of numerator and denominator both equal 1, y2 divided by 1 is equal to 2 as x plus or minus infinity, so y equals 2 is a horizontal asymptote. Y-intercept, y equals 1 / -3 equals -1/3 when x equals 0, x-intercept, 2x plus 1 is equal to 0, x equals -1/2. Check behavior near vertical asymptote, as x3 plus, from right, x slightly more than 3 numerator is almost equal to 7, positive, denominator 0 plus, y plus infinity. As x3, from left numerator is almost equal to 7, denominator 0 dash, y dash infinity. Sketch, 2 branches, left branch starts from y equals 2, or horizontal asymptote, on the left, goes down to dash infinity as x3 dash, right branch comes from plus infinity at x equals 3 plus, falls towards y equals 2 on the right. Worked example 3, sketch y equals x superscript 2 / x superscript 2, 1 equals x superscript 2 / x, 1, x plus 1. Vertical asymptote x equals 1 and x equals -1. Horizontal asymptote, degrees equal, y1 as x plus or minus infinity. Y-intercept, y equals 0 divided by open parenthesis 0 minus 1 close parenthesis is equal to 0, x-intercept, x superscript 2 equals 0, x equals 0. Symmetry, y, x equals x superscript 2 / x superscript 2, 1 equals x superscript 2 / x superscript 2, 1 equals y, x, even function, symmetric about y-axis. For large x, y1 from below, y1 for x1, or above, y1 for x1 when x is not equal to 0. When degree, numerator, equals degree, a denominator, plus 1, there is an oblique, slant, asymptote. Find it by polynomial long division. Worked example 4, y equals x superscript 2 plus 1 / x, 2. Divide x superscript 2 plus 1 by x, 2, x superscript 2 plus 1 equals x, 2, x plus 2, plus 5. So y equals x plus 2 plus 5 / x, 2. As x plus or minus infinity, 5 / x, 2, 0, so y x plus 2. Oblique asymptote, y equals x plus 2. Vertical asymptote x equals 2. Y-intercept, y equals 1 / -2 equals -1/2. X-intercept, x superscript 2 plus 1 is equal to 0, no real roots, discriminate equals -4. The graph approaches the oblique asymptote on both sides. WAEC Further Mathematics questions on curve sketching, state the equations of all asymptotes, find all intercepts, identify any symmetry, find and classify stationary points, using calculus, sketch the graph with correct behavior near asymptotes. Common mistakes, not checking behavior on both sides of a vertical asymptote, the function may go to plus infinity on one side and dash infinity on the other, forgetting to check for oblique asymptotes when degree of numerator equals degree of denominator plus 1, incorrect factoring leading to wrong roots. Key points, systematic approach, domain, intercepts, symmetry, asymptotes, turning points, behavior at infinity. Polynomial and behavior, determined by leading term, and even, a greater than 0 U-shape, and odd, a greater than 0 S-shape going up. Rational functions, vertical asymptotes where denominator equals 0, horizontal asymptote from degree comparison, oblique asymptote from long division. Check sign of function on both sides of vertical asymptote. Turning points, f(x) equals 0, classify with f(x) or sign change of f(x). Symmetry, even, symmetric about y-axis, or odd, symmetric about origin. WAEC sketching questions, state all asymptotes clearly, mark all intercept on axis, show turning points with coordinates, indicate end behavior with arrows.